Myself, Dr. Mohan Dattu Sangle. I have Associate Professor in Rayat Shikshan Sanstha. Today, we are going to discuss the topic that is supercritical fluid chromatography. In short, it is called as a SFC. Here, the introduction to the supercritical fluid chromatography. The SFC was first proposed in 1958 by the scientist Lovelock and first used in 1962 by the scientist Klesper. The principle similar to the high performance liquid chromatography. Sometimes it is called as the convergence chromatography. This chromatography is called as a convergence chromatography. The supercritical fluids are the fluids which are compressed below their critical temperatures yet kept in the liquid state and used above their boiling points with the use of the pressure. A supercritical fluid is a substance with both gas and liquid like properties. It is a gas like property in that it is a compressible fluid that fills its container, and in liquid like in that it has the compressible density. The density is about 0.1 to 1 gram per ml and solvating power. The stationary phase is used in SFC, both packed and tubular column used. The column length is having 10 to 20 centimeter and the inner diameter of the column is 50 to 100 millimeter. The mobile phase is used in the SFC is the CO2, that is carbon dioxide, and in addition to increase the efficiency of CO2 add methanol or ethanol or isopropyl alcohol. Other solvents are also used, that is acetonitrile, chloroform and ethyl acetate. In this chromatography, the pressure is most important part. Therefore, to maintain the proper pressure at about 72.9 atmospheric pressure at 35 degree centigrade temperature. Therefore, this supercritical fluid chromatography is a very recent and versatile tool in the separation technique. Therefore, this chromatography, supercritical fluid chromatography, that fluid is the most important part at the critical temperature. Therefore, both in the form of gas or in the form of liquid, there are a different stationary phases and mobile phase. The column is having tubular column, length 10 to 20 centimeter and inner diameter is 50 to 100 millimeter. We know that the most important part is the mobile phase is a CO2, that is carbon dioxide, plus methanol or ethanol or isopropyl alcohol. Other solvents like acetonitrile, chloroform, ethyl acetate are used, and the pressure is the most important tool. Therefore, supercritical fluid chromatography is a form of chromatography that combines some of the advantages of liquid chromatography with high efficiency associated with the gas chromatography. Therefore, it is the combination of gas and liquid chromatography. Hence, it is associated with some of the best features of each. it is a developing technique. It turns out to be undoubtedly more advanced to both GLC and HPLC for certain types of the application. Therefore, the SFC, the temperature of the column is maintained at a temperature above the critical temperature of the mobile phase, so that the mobile phase cannot exist as a liquid. This is the most important part. By use of relatively high pressure, the mobile phase is sufficiently compressed, so it has the good solving properties of a liquid. Under these conditions, the mobile phase exhibit properties that are intermediate between those of liquid and those of gas. Therefore, in SFC, the diffusion coefficient of solutes are about 100 times greater than the corresponding coefficient in liquids. The viscosity of supercritical fluid are approximately the same as those of the gases. Therefore, the supercritical fluid is formed whenever a substance is heated above the critical temperature. At this temperature, a substance can no longer be condensed into its liquid state through the application of pressure. For example, carbon dioxide CO2 becomes a supercritical fluid at the temperature range 31 degrees centigrade. In this supercritical fluid state, the molecule of CO2 behaves free of one another simply as they do in a gas. Therefore, maintain the temperature is most important point. The critical temperature of fluid used in the chromatography differ very much from 30 degrees centigrade to about 200 degrees centigrade. Lower the critical temperatures are useful from the several standpoints. Much attention has been focused on such supercritical fluid as a CO2, that is 31 degrees centigrade, nitrous oxide N2O 37 degrees centigrade. It is clear from these figures that these temperatures and pressures are well within the opening condition of the ordinary high performance liquid chromatography, that is HPLC. CO2 is most widely used mobile phase in the supercritical fluid chromatography. It is superior solvent for a variety of organic molecules. It transmits in UV region, that is ultraviolet region, that is 200 to 400 nanometer region. It is odorless, non-toxic, readily available and comparatively cheaper. Its critical temperature and pressure are low, that is the critical temperature is 31 degrees centigrade and the pressure is 73 atmospheric pressure. Hence, it permits a wide selection of temperature. Here, the important points which are related to the supercritical fluid chromatography. The first point is the effect of pressure and columns. Second point is the mobile phases. And third point, different detectors are used, that is detectors. In the first point, that is effect of pressure and columns. The density of supercritical fluid increases speedily with increase in pressure. The density of supercritical fluid increases speedily with increase in pressure. For example, it has been observed that the elution time for hexadecane decreases from 25 to 5 as the pressure of CO2 is raised from 70 to 90 atmospheric pressure. So, in SFC, two columns are used. The first one is a packed tubular column and second one is the open tubular column. The first one is the packed tubular column. It is made up of a hard glass or metal stainless steel copper or aluminum tube having the length 2 meter to 3 meter and inside diameter is 2 millimeter to 4 millimeter with porous organic polymer. The open tubular capillary columns are made up of fused silica, while in the open tubular column, in recent analysis, open tubular columns are preferred. The polysiloxanes are used as a column coating material because these are chemically bonded to the inner silica wall of the capillary tubing. In the second point, that is the mobile phase. The mobile phase are available in SFC, that is ethane, pentane, dichloro, difluoromethane, diethyl ether, then THF, that is tetrahydrofuran, and CO2, that is carbon dioxide. The different detectors are used. The detectors used in SFC include the ultraviolet absorption detector, that is first one is the fluorescent detector, second one is the flame ionization detector, that is FID, and other spectral detector. The mass spectrometric detectors are also used. These are particularly well situated to this technique. Here is the instrumental diagram. In this instrumental diagram, there is a syringe pump, sample injection system, column which are connected to the microprocessor, and they are connected to the recorder, and all assembly are followed with the help of the microprocessor control or computer, and it is observed on the display. The computer are operated with the help of the keyboard. The advantages of this technique is a low viscosity, low operating temperature, high diffusion coefficient, high resolution at a low temperature, better technique than the gas chromatography and HPLC. Once again, the advantages are low viscosity, low operating temperature, high diffusion coefficient, high resolution at low temperature, better technique than GC and HPLC. The limitations of this technique is the pressure maintaining is difficult every time. Every time this instrument should be clean, and therefore it is a time consuming. Due to applying pressure, the physical property of the particular gas can be changed. Therefore, this is the limitations, that is pressure maintaining is difficult every time, clearing must, and time consuming. Due to applying pressure, physical properties may be changed. The application of the supercritical fluid chromatography, it is useful for the separation of chiral molecules. It is useful in the purification of pharmaceutical, that is pharma. It is useful in the analysis of natural product. It is useful in the drug industry. It is useful in the food industry and the polymeric industries. So number of applications are available in the supercritical fluid chromatography. The supercritical fluid chromatography, particularly of open tubular type, is applicable to a class of compound that is not easily manageable to either liquid-liquid chromatography or gas-liquid chromatography. These compounds include species which are non-volatile or thermally unstable and do not contain any other chromatographic techniques that can be used for the photometric detection. Therefore, the separation of such compounds is possible with the SFC at the temperature below 100 degrees Celsius by using the flame ionization detector. Thank you very much to listen the careful lecture of SFC. Thank you once again.